in person today, but I want to express my deep gratitude for the company's contribution for equipping our university and my departments. And now the opening of Technocup in our universities is underway. And in this Technocup, my students and the talented us can implement their own projects, innovative projects in CAD/CAM, virtual reality, augmented reality, 3D modeling, 3D printing, and industrial Internet of Things and others. And the first laboratory in the Technocup will be the industrial automation, and this laboratory created is based on the. This laboratory is created based on the PLC manufactured by Schneider Electric. The laboratory is sponsored by. This is. I want to share a screen. Okay. Can we share screen? Can we share screen, please? Fast?
No, but the screen is already shared, so we can see your screen.
Okay. Okay. Thank you. And I have some slides for show, and this laboratory. This laboratory is sponsored by 3 companies: ALD engineering companies, Terawatt Group, and Schneider Electric. And in this laboratory, training in modern technology of industrial digitalization takes place, and this will be expanded the opportunities of our students and scientists to participate in joint scientific project and to collaborate with business. And now let's watch a video of how modern technology work at real industrial enterprise. Now we share some application for this. Now we scientific this laboratory group and
My name is Kenneth Labhart. I'm the innovation leader for the Supply Chain Performance Group.
no.
So, Galina, we lost you. We can see you, but we lost your voice. Now it's okay.
Excuse me, we try to share video now.
That's okay.
One moment, please.
I'm excited to have you here.
I think you have to push the sign from the left corner down to start.
Left corner down, left corner down.
Слева внизу.
There is an arrow there.
Okay.
Еще
We
раз
can
попробуем.
we cannot share application.
No, the application was on screen. So the application was there.
Через экран.
Only screen? Okay.
Просто включите.
Now it's okay. Just start the video.
Today in Lexington, and I'd like to
Okay.
That's okay?
Yes, that's
talk to you a little bit about a digital transformation that we've performed here in an aged facility, a facility that's 63 years old. Some of the struggles that we've had in performing that digital transformation and how we achieved or went through some of the roadblocks to perform that digital transformation.
So we're now on the factory floor. We're standing here in our customer welcome center in the Lexington facility. We make load centers and safety switches here in the Lexington facility, QO and home line load centers for energy distribution, commercial and residential applications.
Не получается вот здесь поделиться? Да нет, не видят. Вот наш экран. Вот Галина Шила,
Which
видите?
one? It's okay.
А, да, где это? Сказали?
Да. Включай, мы сейчас выключим.
Сейчас еще раз попробуем. Подожди.
Так скрин, ты share screen сделал? Share screen сделал?
Тастерский.
Угу. Алло.
Подожди.
Да, а у нас на экране показывают, что не видим, интересно. Включи, все видно, все видно.
And safety switches in single phase, three phase, varying in size from 30 amp to 200 amp varieties here in the facility. We are fortunate enough to be fairly vertically integrated in this facility. All of the high tonnage stamping, the plastic.
Что делать перед этим? Мы просили их на перемене посмотреть.
Galina, I think it's okay. I mean, we can upload this movie also on the website of the conference.
Injection molding, the electroplating for the coating on our current carrying.
Hello, welcome to Lexington, Kentucky. My name is Kenneth Laphart, and I'm the innovation leader for the Supply Chain Performance Group with Schneider Electric. I'm excited to have you here today in Lexington, and I'd like to talk to you a little bit about a digital transformation that we've performed here in an aged facility, a facility that's 63 years old. Some of the struggles that we've had in performing that digital transformation and how we achieved or went through some of the roadblocks to perform that digital transformation.
So we're now on the factory floor. We're standing here in our customer welcome center in the Lexington facility. We make load centers and safety switches here in the Lexington facility, QO and home line load centers for energy distribution, commercial and residential applications, and safety switches in single phase, three phase, varying in size from 30 amp to 200 amp varieties here in the facility. We are fortunate enough to be fairly vertically integrated in this facility. All of the high tonnage stamping, the plastic injection molding, the electroplating for the coating on our current carrying devices, the semi-automated assembly, the painting of the metal itself, and the semi-automated assembly, and even the material conveyance from fabrication all the way through the assembly line is under one roof. We're also fairly highly automated in the fact that we make approximately 2.8, nearly 3 million of these devices a year in this facility from a raw coil of steel, and we're making a little over 800,000 of these safety switch devices in the facility. We've progressed through the plant now to the point of our first station stop where I want to talk about unlocking siloed data. We noticed that we had concentrations of tribal knowledge in the facility, particularly around the knowledge that it takes to troubleshoot the pieces of electronic devices that control our machines, PLCs, PCs, documentation and information on that machine, critical health signals from that machine is difficult, requires a special skill for a person to come, hook a laptop up to a device to troubleshoot it, spend time trying to find documentation. We've implemented an augmented reality application here known as EcoStruxure Augmented Operator Advisor. And what EcoStruxure Augmented Operator Advisor has done for us is using the power of Node-RED, we've been able to unlock that data out of that PLC and deliver it in a real-time image, overlay that data in a real-time image of an actual camera view of a mobile device, such that now a technician or a maintenance mechanic or a supervisor or an operator no longer needs to rely on that tribal knowledge to connect the programming device to debug or troubleshoot. They merely hold the tablet over their equipment, and the critical data pops up in real time and streams live. It's been very exciting for us and is delivered through our Wi-Fi network in the plants to our mobile devices. And let's take a look at one of the 16 different pieces of equipment that we've implemented this tool on, and let's see how it's delivered to us about a 20% reduction in mean time to repair. I want to talk about two of the most important connected products that this facility has in terms of its digital transformation or its digital evolution. The first of which is the Aussie Sense offering, the Aussie RFID offering from Schneider Electric. The conveyor system, at any given time, we move over 7,000 parts in the sky, from a fabrication group through paint and to the final assembly group, in the right order, in the right priority, at the right time to the assembly line. Another very critical connected product for us that we have over 300 of in the facility are the Magellus HMIs. And you'll see those quite frequently throughout the plant. It gives all the operators the ability to visualize, to control their processes in the plant. We rely on them very heavily. This device also has the ability, through the use of two advisor applications known as Secure Connect Advisor and Mobile Operator Advisor, the ability to deliver a cyber secure connection to any device that's on the subset of this device. It also gives you the ability to deliver control anywhere in your facility of the actual HMI screen to the use of Mobile Operator Advisor. So we use these throughout the facility. In this particular case, in our Power and Free system, we can look at information streaming from anywhere in the facility, from any one of our processes. This particular Power and Free system that we're standing in front of now has 8 different control panels like this and over 30 HMIs in the system that we can view what's going on across the plant and see from any individual location in the plant. And those are very powerful for us. So we're coming to a very critical process in the Lexington facility, and that's our paint room. You can understand with a process that's this complex, you know, a 7-stage pre-treatment system, 20,000-gallon e-coat tank, the ability to e-coat 50 million square feet of metal a year. You can understand the complexity and the amount of control and monitoring that needs to take place. So what we've implemented here in our paint system is we've implemented a solution known as EcoStruxure SCADA Expert, based on Intusoft Web Studio. which has given us the ability to visualize and control 167 critical variables in the operation. Now, the really cool thing about the Indasoft Web Studio or EcoStruxure SCADA Expert application is its use of mobile thin clients and web thin clients to deliver that content anywhere in the building. What we're looking at here is we're looking at a live operator view of what the operator is using in the facility to control the processes. If you look through the control room here, you'll see another screen that looks exactly the same because this is a secure web client that has delivered this view or this input into this process in multiple locations throughout the video. So we're at a point in the tour now where I'd like to talk to you about our digital energy management system here in Lexington, Kentucky facility. We utilize two very important tools, one an edge tool and one an app and analytic layer tool. The edge tool is known as Power Monitoring Expert. Power Monitoring Expert lies here at the edge and uses a system of connected meters in your facility to tell us exactly where your energy usage occurs. It also has the ability to extract data from PLCs and PCs, and it lets you descriptively analyze comparisons of that connected meter data with certain things like empty hooks in our paint system, the different types of metal that we use in our plant, gas consumption on a particular day. Gives you the discrete ability to descriptively analyze and dashboard your energy usage in a particular area with very great detail. Then at the regional level, in a cloud application known as Resource Advisor, we extract, our regional operations managers extract these cloud application data as a Power Monitoring Expert to the regional level, and they're able to do plant-to-plant comparisons across Schneider Electric. So for an entire region, we can analyze what we've spent and where we've spent that type of money, compare that to trends in weather, compare that to trends in year-over-year trends or month-over-month trends. Now, the use of this Power Monitoring Expert at the edge and this Resource Advisor at the cloud for a regional look, to give you an idea of how we've impacted our facility, Power Monitoring Expert has delivered us over 20% in energy reduction savings since its installation, over a 70% reduction in our carbon footprint or CO2 production. It's also given us a 5%, over a 5% year-over-year energy savings reduction, and we're on track this year for 11% in energy reduction year-over-year. And the Resource Advisor application has given us over a $6 million savings since its inception here in North America at a regional level. So two very powerful tools for us here in Lexington. I want to thank you for being here with us, Schneider Electric in Lexington, and I ask that you come to the plant when you can in person, and maybe we'll see you then and tell you how we've developed more of our story. Thank you very much.
Thank you, Galina. Thank you for this movie.
Киберфизических систем. Представляем проект «Фитнес-зеркало» на Investment Business School Innovation.
So what is Galina? Can you hear us?
Thank you.
Yes, thank you. Thank you very much. Thank you. So once again, I would like to ask if Mr. Tural Velizadeh is here. Mr. Velizadeh. Mr. Velizadeh, can you hear us?
Yes, I'm here.
Okay, so you have a proposal for a presentation, and because we had this break, maybe you can make your presentation now. Would it be possible?
Yes, maybe. It is maybe.
Thank you. Thank you. So do you have some slides, or would you like just to speak?
I want to just speak about.
Okay. Okay, so please.
Hello, everyone. I'm greeting you from Baku, from Azerbaijan. And my I want to say about importance of Caspian countries for energy security in Europe. The inner circle of the Caspian Basin consists of the 5.
Mr. Verisade, I propose to close the video because the connection is not very good. Maybe you can close the camera to hear you better.
Okay. May I continue?
Yes, please, please.
The inner circle of the Caspian Basin consists of 5 littoral states: Russian Federation, Islamic Republic of Iran, Azerbaijan, Kazakhstan, and Turkmenistan. We know the Reich could be broadly divided the traditional and the 3 newcomers. After the collapse of the Soviet Union in 1991, 3 states were formed on the Caspian seashores: Azerbaijan, Kazakhstan, and Turkmenistan. They proved reserves of natural gas area 27 trillion cubic meters, which is 13% of the total volume in the world. The Caspian Sea has been known for its rich gas reserves for many years. The Caspian is of central interest for European energy security. Also, the supply chain from the region has been traditionally kept under Russian Federation control. Today, the Caspian is also the crossroads between the grid and contradictory energy interests of the Russian Federation and Europe. In 2018, the European Union has become increasingly ambitious in planning the oil pipelines of the Caspian Sea, which exclude the territory of the Russian Federation, and the project of the Nabucco pipeline has been for many years at the heart of these strategic efforts. Already in 2008, the European Union had announced a strategy to open a new gas important routes from Central Asia, the Caucasus, and the Middle East, a project known as the Southern Corridor. In 2013, the Shah Deniz Consortium and its leading stakeholders, it is Azerbaijan oil company SOCAR, State Oil Company of Azerbaijan Republic, British Petroleum, Statoil, Total, Lukoil, Niko, and others, the Turkish National Energy Company, and others, concluded negotiations that have lasted over the decade, approving the Trans-Adriatic pipeline for the final leg of a pipeline bringing gas from the Shah Deniz field in the Caspian Sea to European markets. The consortium made a final investment decision for stage 2 development of the Shah Deniz field, triggering plans to expand the South Caucasus pipeline through Azerbaijan and Georgia, construct the Trans-Anatolian gas pipeline across Turkey and construct the TAP across Greece and Albania and into Italy. The source diversification provided by the Southern Gas Corridor is not a panacea for European energy security, but represents an important step in expanding Europe's energy frontiers towards the Caucasus and potential future partners in Iraq, Turkmenistan, or Azerbaijan. 4.5 years after the inauguration of construction works in Saloniki, the Trans-Adriatic Pipeline, an 800 kilometers gas transportation system crossing Greece, Albania, the Adriatic Sea, and Italy, began commercial operations. A diverse team of industry professionals worked diligently and effectively under challenging conditions to safely deliver a strategic piece of energy infrastructure on schedule.
Thank you very much, Mr. Verizade. Very interesting point, because when we are talking about manufacturing, the future of manufacturing here in the Black Sea region, the existence of oil and gas resources in the region is a very important factor. And from that perspective, your presentation just introduced this perspective. So once again, thank you very much for making this point. Thank you.
Thank you.
Would you like to make a concluding remark or to close?
I want to conclusion for my article. And I would say the Caspian and Central Asian countries have a number of options to diversify their transport routes as well as export markets, while there is only Turkmenistan-China pipeline to reach eastward. 3 routes extend from Central Asia and the West, via the Caspian Sea, via Iran, and via Russia. Thank you very much.
Thank you, Turalde. Thank you very much.
Thank you very much for this conference. Thank you.
So I would like to check if Mr. Krotyuk, Anton Krotyuk, is with us. Mr. Krotyuk? No, he's not. Andriy Puzik. Mr. Puzik? Mr. Puzik? Okay, so
Anton Krotyuk.
yeah, okay.
Yeah,
So Mr. Krotyuk,
good afternoon.
please, you have your presentation, please.
Yes, great. One moment, it is just sharing. It has to load the presentation. I apologize. The software somewhere is just heading, and I'm not able to do anything with this. While it is still loading, a short introduction. My name is Anton Krotyuk, and I'm responsible in our group of companies for our foreign projects, as well as digitalization direction or area of development. And the presentation I'm going to share and I'm going to talk about is dedicated to the maintenance, digitalization and optimization process. So it is a kind of a solution, a kind of approach which we offer to our customer on the road to maintenance digitalization. Sorry, I can't do anything with this software. It is just not responding.
Mr. Krotyuk, are you still with us? So we are talking about digitalization. We are talking about, let's say, advanced manufacturing and the way of, let's say, moving towards the 5G and other types of technology. But sometimes the technology is pushing us. So from that perspective, it is very nice to think for the future, but also you have to understand the constraints and try to stick to them. So yeah, it looks like we lost Mr. Krotyuk, but we have Mr. Puzik. So maybe Andrei, you can start your presentation, and when Anatol will be able to jump again, then we can. Anton is back. So let's check. Anton,
Yes.
Are you ready
Yes.
now?
I hope, yes, I hope that this time the software would work and I could start with the presentation.
Yes, okay, but try to make it condensed because we are just lagging behind. Thank you.
Yeah, not a problem. Do you see the screen right now?
Yes, yes, we can see very well.
Okay, great. So the presentation itself is dedicated to the maintenance, optimization, and digitalization process. And the purpose of this presentation is a kind of present the general approach and the general concept of how we see digitalization process when it goes about maintenance at our manufacturing sites, at manufacturing sites of our customers, of our partners. So the thing is that actually our customers, they would like to do the maintenance as rare as it is possible, just because it is not that cheap. And you have to pay for hours, you have to pay for trainings, some tools, all this stuff. But on the other hand, it should be enough in order to keep machines and all the processes keep on running, and just to ensure proper level of reliability and availability. And then the question is, what could be done with the maintenance of some virtual customer, of maintenance procedures, of maintenance organization? So it could be really the most efficient. So we could really provide the minimum of maintenance hours in order to ensure required level of availability of the equipment. And with this approach when we digitalize the process of maintenance and taking decisions of what to do, where, and how, we found a kind of solution how this process could be really optimized. The thing is that the key thing here, we see the automatic scheduling of maintenance works. So it is not the human or a kind of specialist would plan these works manually, but these works should be scheduled automatically depending on some input data. First is real condition and state of the equipment. And in the best case, even not just the current states, but also a kind of forecast or prediction of how this equipment is supposed to work. The second thing is some rules and recommendation of manufacturers or vendors of this equipment, how often and how this equipment is supposed to be maintained in normal situation. Then, of course, another big thing is the possibility to keep clear track of what is done, when it is done, what is the result of maintenance work, and when it is possible to improve the whole maintenance experience. So this is a kind of concept which we offer to our customers. And then we have a number of tools which would allow our customers to follow this concept and approach. The first thing, of course, is maintenance planning. The idea is that we have a partner. Their core business, they develop this software which could be used for exactly maintenance planning procedures named LD software. And they, excuse me, I hear some, okay. So the thing is, and the idea of this software is that we take and we analyze the whole set of equipment which customer has, and we together we define the exact list of equipment to be maintenance and the equipment for which we are going to do maintenance at all, because sometimes it is cheaper not to do maintenance and then run the equipment to death. But this decision should be done consciously, of course. And then we create a list. Then we create a kind of rules or electronic passports for each equipment when we enter all the data. And then this system creates the schedule of the maintenance works completely automatically. Then we also take data from the automation level, and then we could adjust the schedule according to the current equipment status, or even some predictions which we are able to do for this equipment. Excuse me, do you hear me? Because I hear some noise, a kind of bad connection signal.
No, we can hear you very well. I don't see any other microphone open, but try to move towards conclusions.
Yeah. So the key is that this particular software is able to create the automatic schedule, which could be adjusted with the data from the automation level, from sensor level. So we could really create the schedule which would fit the current status of the machines, of the equipment, in order to do maintenance exactly for the units which really bring maximum risk of downtime or decreasing productivity of these machines. So this software has these tools. The second thing is that when we have the schedule for the all machines, it is split into the schedule and tasks for every shift of maintenance engineers, and then it's dedicated per the number of engineers on site, and then every single engineer gets his task for the current shift to this mobile device with all the instructions, with all the manuals, with all the information which could be needed in order to get this work done, together with some even video manuals when it is needed. All the equipment is supposed to be labeled with some labels, and then engineer goes from unit to unit doing his job and taking reading with this phone these labels and providing some reports, taking some photos of the work done. And in the end of his shift, he's able to upload all the information to the server. And in the end, what we have as the conclusion of this approach is the complete picture of which equipment require maintenance and why it is required maintenance, based of which inspections or which measurements. We also have all the reports. Another stuff which could be really advantageous for the digitalization of maintenance process is the lack of skilled engineers on site. And we really see this problem with which exists by our customers. And what we would offer and what we offer to our partners is another solution from PTC company. I know that they also presented this conference call by company PTC, named for export capture. So the idea is that we could take, customer is able to take his experienced engineer and to create a video, training video, when the whole maintenance procedure is splitted into some steps with the video recorded for every step, with some documents, some manuals, some information which could help. And in this way, we could support the not that skilled or young engineer how to do these operations properly. And in this way, we could really increase the efficiency and the correctness of the jobs, maintenance jobs to be done. And that is really, really powerful tool.
Thank you. Thank you very much. If you would like to make a final statement.
Yeah, so actually the final statement is I just wanted to explain and to provide the general concept of how digitalization process could have real and tangible impact on the uptime of our customers' operations, of uptime of his machines, and could bring positive impact on his production cycle. So that is the idea.
Yes, thank you very much. I wanted just to ask you, Anton, if your software is also connected or is transferring information to the manufacturer. So some useful, let's say, data regarding the service activities, the maintenance activities, and if you have some connection to the, let's say, concept design and to the manufacturing.
Of course, it depends on the customer, because when we have cooperation with machine builders and we support them with creation of such a maintenance server, which is supplied together with machine. And then, of course, the software could be used in order to keep clear track of the correctness and the way maintenance is done. But very often the end users, they say, hey, we just would like to improve internal maintenance procedures, and then it has nothing to do with machine builders or third-party companies.
Okay, thank you. Thank you very much. Very interesting. Thank you.
Yep, thank you for the opportunity.
Now we move further with Andrei Puzik, and he is going to present us very, how can I say, useful introduction on artificial intelligence, robots, and smart solutions that have been developed by an innovative company called Infocom. Please, Andrei. Okay. Now you have the microphone. We have Your presentation, no. Anton, you have to close your screen share. Okay. Now, Andrei, you can share your screen. There is a problem with your microphone, Andrei.
Yeah, and now do you hear me
Yes,
clearly?
yes, now it's clear and loud.
Yeah, okay, great. So yeah, hi all. I want to introduce my name is Andrei Puzik, and I am the IT project manager at the company Infocom Ltd. And we are from Zaporizhia, and we are every day working closely with the robotics and artificial intelligence and smart solutions. So I want to make a short presentation of what we do and how we came to this current point. So first of all, we are the company with the 25-year experience from the automation control process systems. So we developed the solutions that can automate any area of the industry. So our geography of the projects is 33 countries, and it's around more than 500 big projects, all of them, and our customers are such big companies like the Cargill, Bunge, Siemens, Procter and Gamble, and the others. So as I mentioned, we are presented almost in the all industries of the current days. So we don't have the restrictions for which client we can help, yeah, with their problems and the questions. Also, we use the best manufacturer partners in our products, so it's almost all the high quality European brands, and all of them are knowable. Also, we have the 3 offices. The main office is in the Zaporizhia, Ukraine. Also, we have the offices in the Vienna, and Austria, and in the Kazakhstan. So yeah, we covered all 5 level of the industrial automation pyramid, from the devices level 0 and up to the ERP system. So we are
Stas, be okay.
sorry. Mm-hmm.
No, please continue. There is a microphone. I shall mute it.
Okay, so and our innovation based on the computer vision solution, on the robotic solutions, on the smart parking solutions, on the unmanned vehicles technologies, and all of them need to be safety, need to be technological, and need to bring benefits to the or our company or to the end customers use. So it's the close cycle, yeah. And about the smart solution, how it how it as how all want to as it be, yeah. You can see now, yeah. So it's the some smart back, yeah, that follow the pretty goal, yeah. And the current stage of the solutions, you can see at the right picture. So yeah, and our company developed the robotics and produce and manufacture it. It was started just from the idea of our CEO, but nowadays we came to the market and we already have even the few customers from the Europe, USA, and Japan, and we are taking and searching for the feedback to develop our product in this direction. So one of the products is the Robot Tima disinfector. It has the ultraviolet lamp and the recirculator of air. So it's the product that can fully autonomously purify the air and the surfaces in the offices or any other buildings. So it controls or remote by the cloud server or directly from the mobile applications that you can install on any smartphone. So also the one of the kinds of robotics is the Tima Medical. It can be used for the hospitals, for example, to make the contact between the doctors and the patients, to make it without direct contact, for example, to bring some medicine or to speak with the patients just through the tablet that located at the top of this robot. The third type of our robots is the Tima Waiter. It can work autonomously in the restaurants and cafes and can bring the dishes to the customers. It can take the order from the customers. It can be integrated to the restaurant control systems, and it can be controlled by the restaurant administrator. So and the robot guide can be used in the schools or the other studying projects, or can be the guide for example, for the people in the airports or in the exhibitions. So all of these robotics are now presented at the market, and they are real, and they are developed by our company. And one of the latest models are the Tima Logist. And in the warehouses, it can carry the packages from the one point to the another, as with help of the people, or we are working even for fully autonomous robotics. Our previous projects was the autonomous driving project with the Ukrainian automotive company in the Kremenchuk town. It calls the Kras. So around 3 or 4 years ago, we developed and set in the one of the prototypes of the Jeeps, so it can be the fully remote controlled. It has the partly function for the automation driving. It has the functionality for the voice and gesture controls. So it was the one of the pilot project with the Cross Automotive company. And it's the one of the possible solutions. So you can see, for example, now how works the neural network. It analyzes the road without marking, and define the way in which the car can be driven fully autonomously without the driver. So the other areas of our company also connected to the smart technologies. We are producers and manufacturers of the electric vehicle charging station and the software for the controlling all the charging station in the one network. We are presented in Ukraine, and we are the maybe fourth of five at the company at this market for about the quantity of the electric charging stations in the market. With the charging station, we also use the smart parking barriers. It can be controlled from our application. So, for example, when the car came to the electric charging station, it's often when this place is not empty. So in this way we can schedule the charging for exactly the car. And also we are working with the smart solutions for the drivers. One of them is the driver assistance. So this is a solution for the corporate fleets, and it can work on the special devices. So the camera, it installed on the glass of the front glass of the car. So the camera analyzed the current situation of the other machines. It can recognize the road markings, road signs. So it has the speed control, and the other camera, it checks the current situation of the driver. So for example, if driver is going to sleep or talking on the mobile phone or have any distraction, it gives to him the suggestions to keep your attention, or send the messages to the server, to the main operator. So this driver is distraction, and the operator need to be connected to the driver this directly from this device, and to ask him if all okay with the driver, and to check the current status. This is one of the examples how it works. So you can see the car is driving, and it recognizes the road signs and check the distance to the nearest cars. And
so thank you very much, Andrei. Can you make the conclusions?
Yeah. So our company work with the artificial intelligence technologies every day, and our slogan is that some people that think that things can be impossible, but our goal is to do this thing possible with us, with our company. So we don't see any barriers or borders about the future development of the technologies and of our company.
Thank you for this conclusion. It's coming from a very young and eager researcher and engineer, and I hope that you will be able to not to demonstrate this slogan. So once again, thank you very much and congratulations. We hope that we shall have also this presentation to upload it on the website of the conference. Now, I would like to draw your attention that we have still 3 presentations left. Is the presentation of Denis Romaniuk, the presentation of Bogdan Boriak, and we have a kindly request from Professor Nedelcu from Iași, because he has a different appointment later on. And if Denis agrees, we shall change the order. So, Denis, do you have something against? Anything against?
No problem.
Okay. So, Andrei, please stop the sharing, okay? And now, Professor Nedelcu, you have the floor, just 10 minutes.
Okay, thank you. I try to share my presentation. Okay, can you see it?
Yes, it's okay.
Well, so, Mr. President, thank you very much indeed for your kind invitation and accept at the same time to make a presentation. Really, it's the first time when I make the presentation in so short time, because I sent my kind request, but maybe I don't know why the message was not in good time. Now it's okay. So I'm Dumitru Nedelcu, professor from Gheorghe Technical University of Iași, Department of Machine Manufacturing Technologies, and my presentation will be focused on smart 3D printing. So I will skip, because of the time, I will skip some slides. For our guests, our city is on northeast of Romania, border with the Republic of Moldova. So Iași is one of the oldest university environment in Romania, and we have 5 states university. Concerning the research infrastructure, I mean my laboratory in precision mechanics and nanotechnologies, and with the agreement in laboratory of material science, we have 2 field expertise. Yeah? First one, you can see here the CNC manufacturing, additive manufacturing, injection molding technology, and the second one, study of advanced material diagnostics and technical expertise. So, outline of my presentation, I will try so quickly to present some results. Smart manufacturing method and biodegradable material study, material characterization, industrial application, and near future research. I mean, sample coated with ceramic nanoparticles and granules coated with silver nanoparticles. As you can see here, the top smart manufacturing technologies included also the 3D printing or additive manufacturing, hybrid LED design, CNC machining and probing, robot automation, simulation, digital manufacturing, and precision measurement and 3D scanning. So it's important to see a little bit the 5 fundamental aspects of the smart additive manufacturing. And you can see the first one focus on the process knowledge. What means develop theoretical models, how and why defects are formed in the parts. The second one, big data analytics and artificial intelligence. I mean advanced novel analytic approaches to extract and to correlate signature from the large volume in process sensor data to the specific defects. In process sensing, here integrated the sensors inside of the additive manufacturing machine and acquire sensor data as the part is being built. Pragmatic experiment, I mean conduct experiments designed to initiate the part defects such as porosity. And the last one, process innovation, suggest manufacturing strategies to avoid defects inside of the parts with minimal experimentation. So concerning the hybrid manufacturing processes in micro and or nano scale, you can see here one interesting example. I mean, starting with the support deposition, laser machining, part deposition, component embedding, circuit printing, laser machining, final deposition, final machining, and support removing on the end. Of course, there are many industrial applications concerning the additive manufacturing that can be possible to reduce the waste of material significantly. Another industrial application, flexible electronics, and you can see here artificial skin on robotic figures inspired by human skin behavior. So in our research concerning the method and biodegradable material study, as you can see in this slide, we make a short study concerning the input parameters, output parameters, and hard to control factor. I will skip the information from this slide because some of the input and the output parameters you will see on the next slides. Our research was focused in biodegradable material. You can see here the PLA material. You can see here the extruder PLA, I mean as a group of material, liquid wood material, and we got our material from liquid wood Arbo blend reinforced with extruded BDP form, and because of the structure, fiber wood, biofila and biofila silk. Of course, the best results is increase of 100% infill rate. And the first results was focused on DSC analysis. Is important because we have the thermal behavior of the material, green material studied. And you can see here 2 curves. I mean, the first one is for filament, for the wire, and the second one is for printed sample. So the DSC analysis show us the melting point, as you can see, the value for the melting point. The second one show us the crystallization and the glass transition temperature. So also the DSC analysis for the other materials with the melting point, with water evaporation, crystallization, and lignin cross-linking rearrangement only in case of extruded BDP flex material. Tensile tests with the highest results in case of PLA material around 51 megapascal. Results concerning the elongation, results concerning the modulus of elasticity. I mean, important point of view from these results focus on possibility to replace the plastic materials, and you can see here some plastic materials that could be replaced by biodegradable material that we already studied. Results on bending strength and displacement, with also possibility to replace the plastic materials. Another important experimental research focus on DMA, dynamic mechanical analysis, and we can see here in case of our material study, I mean first one BDP flex, you can see here a sharp and narrow peak for damping curve, which means that the material is homogeneous and has behaved as a whole. The second one, the storage modulus curve shape, which decreases sharply, almost vertically more or less, which means that the phase change occurred within a very short time and temperature. Of course, DMA analysis for the fiber wood, and some structure image, both the present of gaps and their size difference for the surface layer and the filling or raster area should not significantly affect the mechanical properties. It's quite important conclusion from this point of view. Also, the same imaging structure for the other materials. The tribological behavior of the material, I mean the friction coefficient and the wear. The wear results were as we expected. I mean the increasing the length of the wear is the same. Are up to the forces applied. So you can see also the some images of worn areas and variation on wear on a certain portion of the ball's trajectory, elastic or viscous behavior of materials. And concerning our results, you can see here our base material Arbo blend and our material reinforced with extruded BDP. We made here some results concerning the DSC. Also, you can see some results concerning the XRD analysis. The diameter obtained is quite good, take into account the equipment in order to use the wire, the filament for 3D printing. Also, another results for Arbofill material. It's also fiber wood. And we try to find some industrial application, and to find, in order to find the feasibility application, we develop an equipment. You can see here an equipment. Yeah, it's the same because we use both equipment in different temperature in a chamber, in the temperature chamber. This equipment simulates the warm wheel assembly operation, assembly that is part of the car whipper's drive mechanism. And we made the results in case of base material, nylon, PLA material, impact PLA material, high density PLA green, and you can see after 105 hours of operating time, around -10 degree, yeah, the results were quite good. We carry on now the research from this point of view for the other materials. So as a near future research, I'd like to mention a little bit that now we are working to the coating sample with the ceramic nanoparticles. You can see here, I mean the first layer is metallic one and the second one is the ceramic one. The best results were obtained in case of Arbo blend, the second one in case of Arbo form, and the third one in case of Arbo blend, of course, with different metallic layer as the first layer.
So thank you very much, Professor Nedelcu. If you'd like to make a final statement.
Yes. Conclusion. The main conclusion is important in order to study the biodegradable material and to replace the plastic material. And I would like to take this opportunity to invite you next year to the MOTEC International Conference. Yeah, will be on FORE in North Romania. Our publication focus on International Journal of Modern Manufacturing Technology. It's the journal with the Scopus indexation, and the ISI proceedings. We are working with IOP from UK. So thank you very much for your attention. So quickly.
Thank you very much. Thank you for all your kindness for joining this conference, and we hope that we shall keep in touch. We kindly ask you to send us the presentation to upload it on the web page. Thank you. Now I'm coming back to Dennis. So Dennis, can you also make it in 10 minutes?
Yeah, sure, I'll try.
Thank you. So Professor Nedelcu, you have to stop sharing first.
Yes,
Yeah, you did it. Okay, thank you very much.
I did it. Yeah, okay.
Dennis, the floor is yours. Dennis.
Yeah,
okay.
Back. I'm trying to figure out the technical problems. Okay, there it is. Can you see it?
Yes, yes. Thank you.
All right. So good day, everybody. Today I would like to present to you a positioning method for construction site that we developed in conjunction with a company called ALD Engineering. At first, I would like to introduce you to applications where positioning actually could be useful. It is usually divided into two main categories, global and indoor. Global positioning is primarily used in applications that require positioning in a large area. For instance, many cars have a built-in GPS, and some even rely on it in part for autonomous driving. It may work great for the automation of the harvesting process, but it has to be coupled with odometry and some optical sensors. This way it would have an accuracy of up to a meter, which would be sufficient for the application. And I think this is what the agriculture companies should be looking forward to. Even though global positioning systems work well in some industrial applications, they may not work at all in others. That's where the indoor positioning systems come in. They are often used in robotics, industrial, and home automation. We should choose indoor over global positioning system in applications where the latter would have poor performance. What's important to understand is that indoor positioning is usually divided into two categories, radio and non-radio positioning. Non-radio positioning uses visual markers, geomagnetic anomalies. Some steel structures have those. And also it could be based on inertial measurements from the inertial measurement unit. But the last one would not be so precise, but would work great in conjunction with other methods. In robotics, it is common to use particle filters for localization. However, when operating in a big empty room where the closest static obstacle would be more than 5 meters away, this approach will not find a valid reference point. In this case, wireless positioning coupled with odometry data and information from inertial measurement unit would work well. On their own, any of these sensors cannot provide reliable data, but in conjunction, they would yield better results. In home automation, geofencing may be useful to detect if a car is approaching the garage door or if something or someone is leaving the premises of the house. Geofencing is actually based on the fact that the strength of the signal drops with the distance between a transmitter and a receiver. So basically the object that has to be tracked is supplied with a wireless transmitter, and then receivers are installed at the points of interest throughout the house. After that, geofence will get tripped if the receiver detects a weak signal from the object that is being tracked. In industrial environment, it is often useful to track expensive portable devices that are in limited supply. Positioning and geofencing may reduce the time necessary to determine if the device is still on factory premises and locate its actual position. It may also be used for personnel and time tracking. This makes it easier to reach them out, find where they are, and actually reduces the time that has to be spent logging the documents. Indoor positioning systems are also necessary for industrial transport robots. There are some positioning systems that offer communications between those robots within the positioning system itself. This is great for robots that you can see on the slide because they could communicate with each other and see if the path they're on would collide or anything else. If we talk about construction, we often have the need for personnel tracking. The solution to this problem differs depending on the construction site. If it is a building project, then we need some kind of modified indoor positioning system that supports 3D positioning or has a clustered architecture, because a building is usually multi-level. It has several stories, and the positioning system shouldn't get confused by multi-level building structures. The device on its own has to be handy, small, and easy to carry. It should just slide into the pocket of a worker, and that's it. Because of the nature of the work, the device may break or even get lost, so the optimal solution would be to develop a device that is cheap, easy to replace, and has a battery that would last in about a week, probably. In this case, a GPS-based solution wouldn't work because it would give us inaccurate readings. It would at best provide us the building's location, but it would be impossible to tell the floor as the person is or even if he is moving. It would also need a separate system to transfer data, basically the location that was measured by the GPS module. The solution for a pipeline construction project would be slightly different, as we would need a less precise system that requires limited to no setup. Global positioning would be applicable in this case, but we would have to take into account the size of the device and the battery life. To meet these requirements, we've decided to base our positioning system on an IoT chip. We chose ESP8266 because they're cheap and pretty easy to purchase in bulk. It is worth mentioning that a system based on 5 GHz band would yield more precise results due to a higher path loss on that frequency, but we have yet to see a widespread 5 GHz IoT chip on the market. There are some, but their cost is way too high. This chip offers some interesting features like limited promiscuous mode, which allows us to inject packets into the network and capture the raw packets from the network. So basically, we can develop our own protocol that would talk over Wi-Fi frequency and send the data about the position. To actually measure the position, we use RSSI. RSSI is the relative receive strength of the transmitted packet. It is attached to every packet that is received from the network, and it could be directly linked to the distance of the transmitter. From the setup that you can see on this slide, It's just a test setup to verify the theory. We have in here a tag, basically a device that transmits the packets and then anchors. There are 8 of them, which are located at an equal interval of 1 meter. So each of them receives a packet from the tag and measures its RSSI. I won't go into the technical details here, but basically, the measured RSSI could be mapped into a distance directly using the logarithmic path loss model. So if we have an RSSI of -50, then that would be somewhere around 0 to 1 meter distance. Once we have a distance from a tag to an anchor, we can use the trial iteration method. It is based on the assumption that if we draw a radius vector from the anchor to the tag that it was measured to, then somewhere on the intersection of all of the drawn circles would be our tag. We don't simply measure the RSSI, we filter it and put it through the path loss model before actually doing a trial iteration. This is a pipeline of what it looks like. So we measure the RSSI, put it through a moving average filter, then the path loss model, and that way we determine a distance to a transmitter and use a trial iteration method to determine the actual position of the transmitter. On this slide, you can see an example of what the system looks like. This is a web interface, and the red triangles are actually the anchors that have a stationary position. The red circles are actually the position of the tags that we captured. And as you can see, it is pretty close to the actual location.
Denis, this is a very interesting presentation, but try to come to conclusions.
Yeah, I'm just about to wrap up. So we made a few improvements to that. And the most important one that I want to emphasize is that we should look into machine learning to filter out data and find out the actual location of the tags. Now, this system is a lot cheaper than other alternatives like Decawave, like several times cheaper. It has an embedded communications protocol, the same as Decawave, so you wouldn't need a separate device for transmitting the actual location. It is capable of sub-meter positioning with the improvements that were mentioned on the previous slide. It is like 20 centimeters or so, easy to build, portable, and cost-effective. I would like for everybody to look forward to the new 5 GHz devices and actually new machine learning applications that allow us to determine the actual signal strengths and filter out the noise. Thank you, everybody, for your time. If you have any questions, you could direct them at me later.
Thank you. Thank you. Put it to the robot. Huh?
Yeah.
Thank you. Thank you very much, Denis. Thank you also for sticking with the time. So in any case, maybe you can send us the presentation to upload it on the website. So now we have the privilege to invite our colleagues from the National University of Poltava, and we invite Bogdan Boriak.
Okay, good afternoon, everyone. Do you hear me well?
Yes, and Bogdan, if you are so kind also to have it in 10 minutes, it would be fantastic.
Yeah, I will do my best.
Thank you. Thank you very much.
The first thing I would like to say that I'm very thankful to giving me such an opportunity to present some ideas that we work with in our university. As it was mentioned before, I am Bogdan Boriak, and I'm from National University Yuri Kondratyuk Poltava Polytechnic. So, and right now I'm into the Siemens lab, and you can see behind me the one of the logo of Siemens: digitalization, electrification, and automation. And today we are going to work a little bit about digitalization and automation topics. So the first thing I would like to start with the case what happened about a year ago when this auditorium was just open. I think that when we got a new equipment, we started working with this. I was surfing the internet to find some information about the new equipment, and I saw the very interesting phrase that I took it into my library of phrases. And that was like the key to fully exploiting the potential of the digitalization lies in the data. And since my topic is connected with the data processing algorithm, we will talk about this data, how to get it, and how to process it. So let's move forward a little bit. By the way, do you see my presentation well? Hello?
Yes, we can see it. Very nice.
Okay. Yeah, so let's move on then. So all starts with the process of the plant we would like to control or research. But this process, it's not isolated inside the black box. Yeah, it is a part of the world. That means that different conditions can influence on our process, on our measurement devices. As a result, we can get, instead of a pure useful signal that contains data about the process or the plant, a distorted one. And that is the problem, because what do we need? We need to analyze this data and make a conclusion. I'm sorry. Okay, fine. And this thing we can do with a microcontroller or different controlling systems. In our case, we will also need to use digital signal processing algorithms, and we would like to talk a little bit about these algorithms. I would like to ask you, or just to explain, that not always we can use some the solution of the problem that was already developed before. In the case if, for example, we cannot know the information about the conditions, and we cannot know the information about the maybe about the process. So what type of the filter, what type of algorithm we would use in this case? And we thought that it would be great to create an algorithm that would work without any additional information about noises or about the process. So that was the aim of our project. We can actually describe it with the requirements. So the data processing method should be able to filter distorted signals, adapt to the change of signal to noise ratio, predict the behavior of the useful signal based on the previous observations, and operate in real-time mode. So I think you will agree that the prediction of the useful signal is very useful nowadays. So we will be like one step forward. And in general, we can conclude all these requirements into one task. That was to design an adaptive digital low-pass filter with an option of signal prediction. So first of all, we analyzed different approaches, different methods of signal filtration, and we stopped on the one that is called double exponential smoothing. This one I think you might see before, and this one is really simple. So we need only to use one coefficient, that is alpha, our smoothing factor, to get a smoothed value or a filtered value. And also it allows to get a predicted value of the signal that will give us an opportunity to analyze the future state of the system. But this method has one huge disadvantage. If we use just simple double exponential smoothing, you will see that our filtered signal will be always shifted in the right side. So it's going to be like delayed comparing to the real one, to the real signal. That is the trouble we faced, and we found the way how to solve this trouble. We created a modified double exponential smoothing structure that is shown on this slide here. So after adding different like 3 blocks of our simple double exponential smoothing and connect it in this way, we were able to get rid of this time delay if our tracking signal can be represented as a function, as a linear function, or even if it's not a linear function like this. And then another question appeared. So you know that we have only one coefficient alpha, and it defines the level of smoothing. And we need to somehow to teach this system to define alpha by itself. But how to do this if we don't have a desired signal? We don't know what's going to be, what signal will look like in the next moment of time. That is why we designed 3 different methods that allowed us to perform an adaptation process of alpha. So, and the most efficient one, I would say that the differential method. In this method, we use 2 different filters. I'm sorry, they are actually similar filters, but with different values of alpha that were shown on the previous slide. And this method allows us to compare the forecast error of 2 filters with different alphas and to make a decision which one shows the better results. And in accordance with this information, we can make a conclusion that like filter with one alpha or another alpha shows better result and change and adjust our smoothing factor. That was proved by different simulations, and you can see the results on this slide. So let's move forward a little bit. The most interesting part for me in this research was how to implement this algorithm. We actually had to take it into account that we need also to teach this knowledge to our students, and the decision was made that we will use a simple microcontroller that is Arduino microcontroller, and it's available all over the world, and you can easily find it even in your city. So to implement it as a part of a code on the microcontroller, first of all, we analyzed the hierarchy of this adaptive filter. And you see that in our case, it looks like a pyramid, probably. So, and it means that the way we program our controllers before was not very nice in this case, but the object-oriented programming paradigm helped us in this case. And we created the source code of this filter, and it allowed us to perform some experiments or to conduct some different experiments in different conditions. We also used the robotic system that was controlled with Arduino Uno and integrated adaptive digital filter. So let's have a look on the results of these experiments. So on the first plot, you will see the 2 different signals. The first one was the signal that represents the distance to the obstacle from the ultrasonic distance sensor. And the blue one allowed us to smooth this distorted signal and to get a little bit better result and a better performance of our robotic system. We also see that our smoothing factor alpha depends, change depending on the noise level that can be applied to or added to our useful signal. As a result, I would like to define main advantages and disadvantages of this type of digital signal processing methods. So the first advantage, it works, and that's great for us. So we designed the method that will allow you to get a smooth signal without knowing lots of information about the system you are going to work with. It adapts to the change of signal to noise ratio, and it can be implemented via modern programming languages, as it's shown on this screen. And also the advantage of this implementation of this algorithm as a source code for a microcontroller allow you to modify this type of a filter in accordance with your requirements of your technological process. We still have some disadvantages that we need to fight against, and we are working on it. That is a loss of useful information during the transient response, as you see here when it just starts adapting. And also, it cannot give you prediction for a long period forecast, because the prediction is made on basics on the previous observations.
Very nice presentation, Bob. Excellent.
The last slide, please. So, and I would like to finish my presentation with one more quote that I saw when I was looking for information about the digitalization processes, and it says that when digital transformation is done right, it's like a caterpillar turning into butterfly. So I would wish you to all your project become sooner or later a real butterflies. So thank you for your attention, and thank you for giving me such opportunity.
Thank you. Thank you for the passion that you put in processing signals and to play with signals. And I wish you success and many achievements in this field. It is nice that at Poltava University you have such a group working in this field, and I'm sure that you could connect also with the other groups within this network, where there are many other talented and, how can I say, very interested groups. So once again, thank you very much. With this said, we could say that we are at the end of the list of presentations, and you have to agree with me that the presentations were outstanding. I mean, first of all, it was a mix, a very nice mix of different subjects, but they were excellent, let's say, prepared, and I would like to thank all presenters for the job they did and for their contribution. So I started this morning saying that this event is dedicated to the 120th anniversary of Zaporozhye Polytechnic. First of all, I was saying this morning that when somebody is celebrating his or her anniversary, they might do many things. I mean, you can go and drink, you can dance, you can play whatever you want to show your joy. And the way in which we behave in our anniversary actually is defining our way of being, our way of feeling the life and the future that we are thinking too. So yes, in the case of Zaporozhye Polytechnic, it was a chance to have such a way of celebrating, starting the celebration, because actually the celebration will be tomorrow, starting to think to the future. And what we can say, the future is really bright. I mean, I'm very, very optimistic after hearing all these very nice presentations today, because we can see that we have excellent researchers, we have very talented young generation, and all of them, they are very eager to demonstrate that nothing is impossible. So from that perspective, I'm really happy about that. I wanted maybe to come back to Galina and the group from Zaporozhye. If I don't know if Professor Belikov is still in the room, but if somebody from there would like to say a few words.
For sure. Well, on behalf of our university, we are really deeply appreciate your work, your attention to us, and it was just a great pleasure to listen to young researchers with their brilliant ideas, the prospects that they opened, and the slogan, "When impossible becomes possible," due the efforts of young scientists and young, today maybe students. That's why we are very, very grateful. Thanks a lot. Galina Nikolaevna.
Thanks a lot. Thanks for interesting reports, and it is very, very fruitful for us.
Yes, and they're really precious. We are thankful, and of course, I think that 120 years actually quite a lot, but we feel still young, and we have a lot of future perspectives before us. We are eager to be involved in the international community, and of course, we cherish this communication that we have, and especially in the conditions of quarantine of this corona, such communication is even more dear and efficient for us. Thanks a lot. I do mean it. Thank you.
Thank you very much. If from the audience, is somebody willing to say a few words? Anybody? Okay, so it was quite a long, let's say, period of presentations, and many of them were very dense. I kindly ask you, for all of you who are still in the front of the computers, to open your camera, because we want to make a picture, screenshot with the cameras open. So would you be so kind to open your cameras? Hello, so who are still there, please open your cameras. Please open your cameras, because we want to say happy anniversary to Zaporozhye Polytechnic. So everybody there, my colleagues Andrea and Mihaela, they are taking care of the screenshot. So once again, happy anniversary. Goodbye. Bye, everybody. See you in such occasions. Goodbye.
Bye. See you.
Bye.
Thank you very much. Thank you.
Goodbye. Thank you. Bye.
Teşekkür ederiz Edem Hanım.
Rica ederiz. Sağ olun.
Sağ olun.